All right, pre-calc students, today we are looking at the law of sines. So here is your introduction to the law of sines. First of all, in any oblique triangle, so triangles where all the angles are different, not a right, it could be a right triangle, but any triangle that is not a right triangle, there are relationships between sides and angles. And that relationship is called the law of sines. Okay. In any triangle, if this is capital A the angle or the vertex, then this is lowercase a the side. They are always across from each other. Capital B the angle, this is lowercase b. Capital C the angle, this is lowercase c the side. Okay. Here is what's called the law of sines. This formula tells us that the ratio of the sides to the corresponding angles are equal. So actually what you're looking at is a proportion. We don't use all three of them, we'll just use two pieces. So we have a proportion that we're going to set up and solve. All right, so let's look at our first example. In my first example, we are looking at a triangle where we have these two given angles and this side, 8.5, and we're going to be looking for lowercase r. Notice I did not use any letters of A, B, and C because all we have to worry about is setting up a proportion. This is the side that we're looking for, which is across from this angle. That is one ratio. R over sine of 70 equals, here's my other ratio, 8.5 the side over this angle. So 8.5 over the sine of that angle. Well, you know that angle. All the angles of a triangle add up to 180 degrees. So all we have to do is 180 minus 70 minus 30, and that gives us 80 degrees. So this angle is 80 degrees. Now everything is calculator work. All I have to do in my calculator is multiply these two and divide by the sine of 80. So this is what it's going to look like in your calculator. So I'm going to cross multiply or multiply both sides by the sine of 70. So I'm going to put 8.5 sine of 70 divided by sine of 80. Okay, make sure your calculator is in degree mode. Batteries are low. It's in degree. And I'm going to type in 8.5 sine of 70 divided by, go over there, close that parentheses, divided by sine of 80. I'm going to hit enter, and then all I have to do is just round off to, we'll round off to the nearest hundredth. So I have 8.11. So side R is equal to 8.11. Well, we round it off, that's your approximation. The little squigglies. Okay. Okay, well, let's look at our next example. In my next example, I didn't put any letters on the triangle, which is fine. I don't need any letters on the triangle. This is the side that we're looking for, which is across from that angle. There's my first ratio, x over the sine of 40 equals. Here's the only side that we know, and it's across from this angle. So 4 over the sine of that angle. Well, again, 180 minus 40 minus 45. Type that into your handy-dandy calculator. We have 95. So that angle is 95. Okay? So this point right here, you don't need to write all this out. You should be able to go from here, type right into your calculator, and we'll round off to the nearest hundredth again. So here I am, right in my calculator, 4 sine of 40, close parentheses, divided by sine of 95. Close parentheses, hit enter, and there I go, 2.58. All right, last question. Now, in this question here, we have these two sides in this angle. We're actually looking for an angle. Oh, so this is the angle that I'm looking for that's across from that side. Well, that just means, here's my ratio, 10 over the sine of x equals, here's the side, over angle 20, 13 over the sine of 20 degrees. Okay? Again, we're looking for this angle x. Since this is an angle, so eventually in the calculator we're going to have to do inverse sine. Okay? So what does that mean? So eventually in the calculator we're going to have to do sine with the -1 of whatever that decimal value is. All of this can get typed right into your calculator. Okay. We've talked about proportion solving in the past. Okay. We're going to multiply these two, and I'm going to cross multiply those, and eventually this is what it's going to look like. Sine of x is equal to 10 sine of 20 divided by 13. Okay, what I did, I switched these two spots because I just cross multiplied. I can switch them. So it's 10 times this divided by the 13. So there's my sine of x. So what I'm going to do in the calculator then is, just to save some time, okay, so I'm going to do my 10 sine of 20, close parentheses, divided by 13, and then I'm going to hit enter. Now I'm going to do inverse sine of that answer. So second sine, and then I'm not going to type in all those numbers. I'm going to use my second ANS. Close parentheses, hit enter. Now, what you are looking at is the angle. So here's my ANS. So what you are looking at is the angle in decimal format. Okay, so right now your angle x is equal to 15.25 ... On the last homework assignment, I asked you guys to look up how to change these angles to degrees, minutes, and seconds. And on the graphing calculator, you would hit the second button, then you're going to hit the apps button, because you see right above it in blue is angle. And then we're going to do number 4. And that's DMS, degrees, minutes, seconds. So we're going to change that to degrees, minutes, and seconds. And we're going to round to the nearest 10 minutes. Actually, no, we're going to round to the nearest minute. All right, nearest minute now. Here's the degrees. That's 15 minutes. That's 13 seconds. Okay. Now, since we're talking degrees, minutes, and seconds here, seconds are out of 60. Minutes are out of 60. So our halfway is 30. 1 is not halfway, so we are looking at 15 degrees, 15 minutes. So angle x is equal to 15 degrees, 15 minutes. So we rounded to the nearest minute. Okay. Now, what information did we have in order for us to use the law of sines? Well, if you look at the formula, I'm going to cover this one up. I have two sides and I have two angles, but they have to be in a certain order and a certain position. Yes, that goes back to your geometry days. So in geometry, what you are looking at right here is two angles. So we're looking at angle. This is a side and that's an angle. So we're looking at angle, side, angle. So info that we need is angle, side, angle. Well, this one unfortunately is another angle, side, angle. I'm going to write down over here, the other piece that we could use is angle, angle, side. Yes, I know, that was from your geometry days. So what this is telling us, as long as I know two angles, I know the third angle because all the angles of a triangle add up to 180 degrees. And that's going to find us a side. Okay. In this triangle over here, we're actually looking at angle, side, side. Yes, the ass of the triangle. Remember in geometry, that was called your ambiguous case. And that will find us another angle. So we have to have this information. Any two angles to find a side, then or if we have one angle and the side, so angle, side, side, then we're finding the angle. This is how we use the law of sines. Okay, so here's a nice little intro to it. We're going to look at some word problems. 4 word problems, and then you'll be able to do your work. So we're not going to do question 5 at the bottom, so I'm only going to focus on 1 through 4. Okay, so first, they're talking about triangle HEN, so we have to draw a triangle HEN. Okay, angle E is 49, angle N is 57. So if you know these two angles, you automatically know H. Little e is 8. Our job is to find little h. So right now we have angle, angle, side. Angle, angle, side. Our job is to find little h. So we're finding this side right here, h. Remember your formula. I'm just going to use I'm going to put 2 ratios together. Little a over the sine of capital A equals little b over sine of capital B. Remember, I put the sides on top over the corresponding angles. There are some books, you'll see them online if you look this up for other videos. Well, they have these upside down. They'll put sine of capital A over little a equals the sine of capital B over little b. The formulas are exactly the same. They just, I don't know why, they just put it upside down. I was always taught this. I always teach this. You will see this in books, movies, when you're watching other videos. Okay. So little h is across from capital H. Since we're looking for little h, we need to know this angle. Again, 180 minus your 49 minus your 57. Okay? I'm going to type that into my calculator. 180 minus 49 minus 57. That gives us 74. So I have h over the sine of 74 equals 8. So there's my 8 and 49. There's my h and 74. Equals 8 over the sine of 49. And then everything else is in the calculator. Round to the nearest tenth. Just type it right into the calculator. 8 sine of 74 divided by sine of 49. Close parentheses, hit enter, and we have 10.19. So side h is approximately 10.19. All right, now this one, triangle gem. We have to be able to type in the 37 degrees, 20 minutes, and the 51 degrees, 30 minutes in your calculators. If you have a scientific calculator, some of you may have that DMS as an actual button. Some of you may have stuff that looks like this. They mean the same thing. That's your degree symbol, that's your minute symbol, that's your second symbol. Just keep hitting this button. So 37, hit the button. 20, hit the button. Okay? All right. So here's my triangle gem. So G is 37 degrees, 20 minutes. E is 51 degrees, 30 minutes. That's E. M, little m is 125. And we're finding little g. Little g is right here. So here's a little g. Here's the 125, the only side that we know, which is across from this angle. We know this angle, we just have to subtract from 180. So we're just going to do 180 minus those two angles. So 180 minus your 51 degrees, 30 minutes, and then minus your 37 degrees, 20 minutes. Some of you could probably do that in your head. You're looking at 88 degrees, 50 minutes. Okay, so 180 minus 88.50. You should be able to, you could do that in your head. That would be 91.10. So when we do this, we'll have 91 degrees, 10 minutes. All right, I want to do it in the graphing calculator. 180 minus 37, second angle, number 1. 20, and I got to do second angle, number 2. Minus 51 degrees, 30 minutes. 51, second angle, number 1. And 30, second angle, number 2. Okay, hit enter. That gives us the angle in decimal format. Then we have to do second angle and then number 4. Scroll down to number 4, hit number 4. There's your DMS, hit enter. 91 degrees, 10 minutes. Okay. So this angle right here is 91 degrees, 10 minutes. Okay. Got the hard stuff out of the way. Everything else is done. Writing out the formula, and then everything else is done in the calculator. So here's my 125 over sine of 91 degrees, 10 minutes. And then we're looking for little g over the sine of 37 degrees, 20 minutes. Okay. Everything else is done in the calculator. So 125 times the sine of 37 degrees, 20 minutes. So 125 sine, I don't have to say times, the calculator knows, sine of 37 second angle number 1, 20 second angle number 2. Close parentheses, divided by sine, and I'm actually going to, on the 84, I can scroll up and grab that 91, hit enter, and it'll put it right there for me. Close parentheses, hit enter, and then, so side G is approximately, we're rounding to the nearest tenth, 75.8, because we did our rounding off, so we're to use approximations. Okay. Finally, number 3 and number 4. 3 is going to be a little bit more challenging because of the degrees, minutes, button stuff. 20. Number 4 will be easier because we don't have to worry about that. Okay. Number 3 says the angle of elevation to the top of a building from a point on the ground is 38 degrees, 20 minutes. From a point 50 feet closer to the building, the angle of elevation is 45 degrees. What is the height of the building to the nearest tenth of a foot? This is what people actually used to do a long, long time ago for surveying. So here's they started here. They looked to the top of the building, and they said 38 degrees, 20 minutes. They walked in 50 feet. They did another measurement. They looked to the top of the building. They said 45, and they could figure out the height of the building. This is what I call a double law of sines problem. In other words, we have to use the law of sines twice. There are 3 triangles in here. 2 are right triangles. Okay? Here's a small right triangle, here's the big right triangle, and here's this obtuse triangle. What I always do is I find the length of this side right here, I'll call it y, because it's being shared by both triangles. You could do this side over here if you chose to. It does not matter. It does not matter. In any event, we need to know the angle that is opposite 50. Okay? We cannot do this in one step because in these two triangles, the only side that we have is 50, and that's not in this big ginormous triangle. It is only in this obtuse triangle. Okay? So I need to know what this angle is in order to find this length. Okay? So this y is across from this angle. So y over the sine of 38 degrees, 20 minutes is equal to the 50 over that mysterious angle. I'm going to put a question mark there. All right, well, we can find all of these angles of this triangle. If this is 45 degrees right here, then you know these two are supplementary. So that makes this 135. Then all I have to do is just add these two up and subtract from 180, and I can find this angle. Okay? Then I'll show you a shortcut way. So what we're going to do is 180 minus 135 minus 38 degrees, 20 minutes. Then I'll show you a shortcut way. Going back to your geometry days. So 180 minus 135 minus 38 degrees, 38, second angle number 1, 20 minutes. Second angle number 2. Like I said, some of you could probably do that subtraction without the graphing calculator. So 6.666, so second angle DMS number 4. So 6 degrees, 40 minutes. So this angle is 6 degrees, 40 minutes. So sine of 6 degrees, 40 minutes. All right, I wanted to show you a shortcut to that. The shortcut would have been this, called the exterior angle theorem of a triangle. These two angles will add up to that outside angle. So this is angle 1, that's angle 2. That will equal this angle out here, this angle 4. So angle 1 plus angle 2 will equal angle 4. So what does that mean in our triangle? All I have to do is subtract these two, and that would have given me 6 degrees, 40 minutes. I'll write it out. 45 minus 38 degrees, 20 minutes would have equaled our 6 degrees, 40 minutes. See? 45 minus 38, 20. 38, second angle 1, 20, second angle 2. There's the 6.666, so I don't even have to bother. You already know it's going to be 640. Okay, shortcut, subtract those two. All right, so now we have to find angle y. Side y. And we're not even going to bother rounding off, so I'm just going to do law of sines on this answer. Okay, so 50 times this divided by sine of 6 degrees, 40 minutes. So 50 sine of 38 degrees, 20 minutes. 38 second angle 1, 20 second angle 2, close parentheses, divided by sine of 6 degrees, 40 minutes. Sine of 6 second angle 1, 40 second angle 2. Close parentheses, hit enter. So 267, so this angle y, that side y is 267.1289182, dot, dot, dot. Goes on and on and on and on. All right, now let's look at what we have. So that means we know this side right here is 267.128, dot, dot, dot. Okay? I'm going to do law of sines again. I'm looking for the building. I'll put X here. So x is across from 45, and then this 267 is across from 90. So there's my second law of sines. So I have the 267.128 ... is across from the sine of 90 equals x over the sine of 45. And then we will have our answer, and we'll round that off to the nearest tenth. Some of you may have remembered from last year, sine of 90 is equal to 1. Well, or else we'll definitely pick it up this year. So in any event, so it's this answer right here that I'm pointing at. I'm just going to hit times sine of 45. Sine of 45. And then divided by sine of 90. And there you go, 188. We said nearest tenth, so 188.9. 188.9. Okay. I'd say do the next one on your own, but I know we can't do that. So number 4. Notice I made it a lot easier. I didn't put any minutes in here. We're finding the length of the antenna. So the base of a television antenna is in line with 2 points on the ground due west of the antenna. The 2 points are 100 feet apart. So point 1, point 2, they're 100 feet apart. The angles of the elevation of the top of the antenna are 30 and 20. Find the height of the antenna to the nearest tenth of a foot. So eventually we're going to find this. This picture and this picture are nearly identical, different numbers. I'm going to find this side again. Okay? Notice I use numbers are a lot easier. And I'm going to do my exterior angle piece to find that angle. Remember, this is the angle that's across from 100. That's the only side that we have in this obtuse triangle. I can find this angle and then subtract from 180. If you want to do that, you go right ahead. If you subtract from 180, this is 150. Okay? Or 30 minus 20 is 10 degrees. Okay? All I did was 30 minus 20. I did not do the 180 minus 20 minus 150. Okay, so here we go. Sine, 100 over the sine of 10 degrees is equal to y over the sine of 20. Okay? And then once we get that answer, it's whatever that answer is. There it is. It's whatever that answer is over sine of 90. And that's equal to the x over the sine of 30. So whatever this answer is, we put right here. And then it was just more calculator work. So whatever this answer is, we're going to put right here. Okay? Let me clear out here. So we had 100 times the sine of 20. So 100 sine of 20, close parentheses, divided by sine of 10. Close parentheses, hit enter. So we're looking at 196 and change. So 196.96 ... And now all I'm going to do is this answer, that answer, times, so answer times sine of 30. Close parentheses. And now I am not even going to divide by sine of 90. Okay? And we have our 98.5. Round to the nearest tenth, we have x is equal to 98.5. Oh, excuse me, approximately, we round it off. Okay? Here's why I did not divide by the sine of 90. I told you sine of 90 is equal to 1. Sine of 90, enter 1. Okay? All right, that's law of sines, folks. I know I threw a lot at you in this piece here. You got a couple days to work on this assignment because soon we'll be doing the law of cosines. Okay, bye.